systems of equations. What we're going to work with, chapter 6, about solving systems of equations. Systems of equations are ones where you have where you have more than one equation, and you're looking for things that will be solutions to both of them. XY coordinates or XYZs, you can have 2, 3, 4. I've done them with 5 variables or more. Not something you guys are going to do. You're not going to get more than that in here. But what you're looking for is you're looking for solutions, numbers that will work in every equation you have. That's what a system of equations is. In particular, we're going to work with linear equations. And so system of linear equations, guys, get this written down on your notes. A system of linear equations, which is what we'll be doing within here, 2 or more linear equations that are related to each other.
I know there's none in that.
I know. System of equations, 2 or more linear equations are related. The solution of the systems. Any ordered pair that makes all of the equations true. Now, we're going to do today by graphing. That's what we're going to be using the Chromebooks for, is to do the graphing rather than graphing by hand. You're going to do all your graphing on the Chromebook. Okay. I'm going to be honest with you. Solving a system by graphing is an extremely inefficient way of solving a system. But it provides the best visual of what a system, of how to solve a system. Okay, it provides the best visual for how to solve a system. What is my solution? My solution is the shared ordered pairs. Now, if we look at these 2 equations down here, okay, I have the equation y equals 1/3 x plus 1, y equals negative x plus 5. So this line here is the solutions for that one. Every point on that line is an xy coordinate that makes this equation true. This line here is every single xy coordinate that makes that equation true. My solution to the system is the one place that they have in common. If you have 2 lines crossing each other, there's one place and only one place that works in both of them. In this case, it's the point 3, 2. If I take 3, 2 and plug it in here, it works. If I take 3, 2 and plug it in here, it works. This is an important idea, guys. This is the idea. This is the big idea behind everything else we're going to be doing the rest of this chapter. I have 2 equations. I have this equation and this equation. What works in both of them? Graphing gives you a picture of that. That's what graphing does. Because a linear equation has an infinite number of solutions. Every single dot on that line, and there's an infinite number of dots on that make up that line, is a solution to that equation. Every dot on this line is a solution to the other equation. There is only one place where they both have the same point. That's the solution to the system. This works in the system of equations, both equations together. Graphing is excellent for giving you a visual of what's going on. That's all graphing really. It's not an efficient way to do it. If you're doing it by hand, you've got to be really good at graphing to get a good point. It's not an efficient way of solving a problem, solving a system. We will learn better ways. But I like this because it gives you a visual picture of what we're talking about. Okay. Now, not every time do we have 2 lines crossing each other. We have 2 other possibilities. These 2 lines here, where do these 2 lines cross? Where do these 2 lines cross each other? Never. They're parallel lines. They never cross. If you have parallel lines that never cross, you have no solution. That's what that symbol stands for. It stands for no solution. No solution. Okay. Then the other one, and I've got to move this up so you can see it better. And then the other one, it's kind of hard to tell for you guys, and definitely on the printout that you have, but there are two lines here. So you can pull the one back. So where do those two lines cross each other? Everywhere. Everywhere, right? They cross each other everywhere. You have an infinite number of solutions. Grab a Chromebook. You have an infinite number of solutions that they cross everywhere. Okay? So we have three possibilities. There's one solution. The place they cross each other. You have no solution. They never cross each other. You have an infinite number of solutions. They are the same line written in two different ways. That's what happens with this one. They're the same line written in two different ways. Okay? Questions? Big ideas, big concepts. Okay? Big ideas, big concepts going on here. So here's what we're going to do, and here's how I want you to do this. Now I'm going to go back and forth, and I can graph pretty good by hand. I've been graphing like crazy. But here's what I want you to do. Your first set of equations on your Chromebook. Okay? Go into Desmos. Here's what I want you to do. Your first equation on that sheet. There you go, paired systems right here. And the ones that were on there. The first one, y equals x plus 2. Type that in here, y equals x plus 2. Y equals x plus 2. Look at that. Graphs it nice and pretty for you. I want you to, on your paper, sketch that graph. You've already graphed it. Just draw approximately what it looks like. I'm not looking for perfection. If I was looking for perfection, we'd do other things. Okay? So we're on the site, desmos.com. Like I said, I use this site an awful lot for an awful lot of things. It's really, really, really cool. I use it to check my work when I'm doing a test. I do it for the answers to double check if my algebra works. Okay.
Okay, so wait, I'm on Desmos.com.
Yeah.
Go to the graph part, but it's a safe Here it is. They spelled graph wrong.
Because you spelled Desmos.com wrong. It's spelled with Z, not an S. Sorry, that's on tape. I won't say who it is.
It's called.
I had a teacher that used to talk about students. He says, I won't tell you who it is, but his initials are, and then they say the kid's name.
Nah, that's a good one.
Yeah, no, he was a mean teacher. So I don't teach like him. Okay, so how many lines do we have in the system? We have 2 right now, right? So to type the other one in, you just click right below, and it'll open up a new box. Click right below where the equation that you typed in was. It'll give you a new box. And then type in the other equation, 3x minus 2. Y equals 3x minus 2. And it graphs the other one.
Hey, that's pretty good.
Like I said, it's a lot easier than trying to do it all by hand now, isn't it? So once again, I just want you to give me a rough sketch of the 2 lines. And then we're looking for, what are we looking for? We're looking for the solution, right? Where did they cross? Well, here's one of the nice things about Desmos. It's really easy to tell where they cross. They cross right here. And you click on it, it makes a little gray dot. You tap on that little gray dot, it tells you the solution. 2, 4. They cross at the point 2, 4. So write down here what's your solution, 2, 4. Okay. So let's go back to your notes. So I want to be clear what I want you to do. You're going to do the first line, which looks about like that. You're going to do the second line. Which looks about like that. And then you're going to tell me by Desmos they cross at 2, 4. I am not looking for perfection on your graphing. Okay, I'm not looking for perfection on your graphing. What I'm looking for is I want you to do this and come up with a solution. Does that make sense? Desmos is a wonderful tool for graphing. Wonderful tool for stuff like this. It really is. It does some really, really cool things. Hopefully, as you progress through years, you'll see stuff that's got a calculator built in on it and other stuff. But it does some really, really neat stuff. It doesn't do everything I'd like it to do, but considering it's free, I can't really complain. You know, so if you have to do graphing or stuff, this is also a great way of checking your answers when you're doing homework and things. Okay? Questions? Okay, do the next two. So we go back to Desmos, and you want to put 2 new lines on, but you don't want the old ones there. What do? Click the X's, they go away, type in your 2 new equations. Do that. Figure out where they cross.
Do you want to like save this or what?
Nope.
Or just exit?
Nope. No. You don't need to exit. Just on with the old equation. So if I type,
press the backspace.
actually see where there's a little X. Cool. The X.
Yeah.
Press on that. It clears everything, and it'll clear the graph that goes with it. Y equals 2x plus 4. Y equals 2. There we go.
Whoa.
And where do they cross?
Oh,
They cross at -2, 0. So write down on your notes, sketch those 2 graphs. And here's what you might want to do is you have where they cross at -2, 0. My graphing is, my thing's not working too good. You got one that goes like this, and the one that goes like that, and that's where they cross, at -2, 0. Okay? Questions? So here's what I want you to do. Actually, I want you to skip to the next one, the word problem. Okay? Let's skip down here to the word problem one. So I can help you write the word problem. Help take the hard part out for you. Okay, so you got 2 alligators. You know how to tell whether you're being eaten by an alligator or a crocodile?
One is a lumber now.
Whether they eat you now or eat you later.
That's alligator. I get that.
Or see you after a while or see you later.
See you later. And a lot.
Sorry.
But there's in a while crocodile.
Okay.
After a while.
It's in a while.
Okay. So let's do this. Alligator number 1. How much does it weigh to start with? Alligator number 1. How much does it start with? How much to weigh? Starts 4 pounds. How much does it grow per month?
1.5 pounds.
1.5 pounds per month. So our slope is its rate of growth per month. I go, ooh, 1.5, that's my slope. It starts at 4 pounds. That's my y-intercept. So the equation for alligator 1, y equals 1.5x plus 4. So the other equation. It starts out at 6 pounds.
Big baby.
It grows 1 pound per month, so its slope is 1. So the equation for this, my y equals 1x plus 6. Graph those two. Where they cross gives you when the x part when they cross is when they'll weigh the same. Does that make sense? Okay. So here's what I want you to do. Listen closely to my instructions. Eyes on me. Eyes on me so I know you're paying attention to me. Okay. Finish the notes. Go through the notes, graphing the equations. Sketch the graph, just a real light sketch the graph, write down the solution where the two lines cross each other. You will see the last page of this section. It has homework problems. Get the book. Use Desmos to graph the lines from the book and sketch them in on the equation, on the graphs that are provided along with the solutions for each problem. Does that make sense? So that's what I want you to do. I want you to not graph these by hand. I want you to graph them using the computer. Okay? And this is free. You can do this anywhere where you can go online. I've actually downloaded the app on my iPad. So that's apps that you can download. I have it on my phone too, which is an Android product. I have a Samsung phone and I got an iPad. I've downloaded Desmos. It works just fine on those. So it's a nice free thing to have to help you out while you're doing your math. Really, it's a nice one. Okay. As you get farther and farther along, it'll be more and more useful for you. Okay. Any questions? Yes. Okay. Hang on.